Hello and welcome to this TechBlick Masterclass on 3D printed electronics. My name is Martin Hedges. I'm the Managing Director of Neotech AMT GmbH. So firstly, what is 3D printed electronics and what are its benefits? 3D printed electronics is the addition of electronics functionality through printing processes, sometimes in combination with classical surface mount devices. So this is components such as chips, resistors, LEDs, whatever happen to make up the rest of the circuitry, either onto and or into structural components to create mechatronic systems. So we can see two examples here. On the left-hand side, we have the case of printing on a 3D substrate. In this case, it's an injection molded plastic component, and you can see various components mounted onto the surface and the printed electronics functionality connecting it all together. On the right-hand side, you can see the printed electronics are actually embedded inside a mechanical structure. So what we have here is a body built by classical 3D printing, in this case an SLA process. This is the yellow material, and the electronics are contained within that. So why is 3D printed electronics used? What are the benefits of doing it compared to classical electronic systems and mechatronics when the electronics are put into a final mechanical housing to make the mechatronic device? Well, there are three main aspects that need to be considered. The first one is design flexibility. So by removing a printed circuit board and putting your electronics functionality directly onto the mechanical structures or into the mechanical structures, you end up with highly integrated products. You've got a flexibility of shape. You're not limited by the 2D nature of a printed circuit board. You've also then got the benefit, potentially, if that's of interest, of miniaturization. You're removing a big component, the PCB itself. So you can shrink everything down. And then you can also add new functionality. So effectively, you're taking a dumb piece of structural material and adding electronics functionality to that. The second aspect really is about economics. So really the economic benefits that you might get will depend, again, case by case, application by application. But the economic benefits generally stem from things such as the reduced part count. Firstly, you don't need a PCB. You don't need to pay for that. You can also have shorter process chains. You've got less assembly. One clear advantage, you don't have to put your PCB and wire that into a mechanical structure because you already build it directly into the device. You've got reduced materials usage because using printing techniques, you're working in an additive way. You're not working in the very wasteful ways that classical electronics do, where you cover an entire PCB with copper, then you etch that away and you remove material. And you've also got increased reliability, in the sense that you've got fewer interfaces. You're integrating. You haven't got wires and connectors, as many wires and connectors as you would have using classical electronics. So that can give you some economic benefits. And then the third point, which is of equal importance, is the environmental side of things. You've got this reduced materials mix, so you're using less resources. You're simplifying the recycling because you're not mixing so many materials together. So what I mean by that is if you think about a classical PCB, you've got glass fibers plus some resin plus the various lacquers that make up the mechanics of the board, which you no longer need. So you don't have to separate those materials. And also the electronic circuitry is generally printed with one material. So you might have a silver circuitry as opposed to copper, nickel and then gold plating on top of each other, all combined together, which then in a recycling process you have to separate those materials. You've also got reduced material quantity. Again, you're working in an additive way, so you're saving material, you're not wasting material, and the number of parts, the reduced materials mix ties into that as well. And there's also potentially some environmental benefit to be gained by having reduced parts tourism. You have less components, you have less parts tourism of your electronic parts flying 3 times around the world before they get into the final device. So what are the commercial processes for 3D electronics? So what I've tried to do here is give a little bit of an overview to show where sort of the printing sits in with other techniques that are currently established. So one very common way of making 3D electronics at the moment is by two-shot molding. So if you do that for very high volume, so you injection mold the circuit in a material that is active for plating, so it can be plated, and then you overmold that with the main mechanical structure. And as I say, that process, that part is then plated copper, nickel, gold, and then assembled with solder and surface mount devices in the normal way. Another very well established methodology is laser direct structuring, where you have an injection molding material that has a special additive in there, a sort of metal organic compound, that when that is activated with a laser in those particular areas, it becomes active and you are able to plate on that. So you would structure the circuitry using the laser, you write that circuit, and then the plating using normal processes. You put on copper, nickel, gold, and put on your solder, and then your surface mount devices. There is a version called LDS Proto Paint, where you actually, instead of having a complete mechanical material, the injection molding material, you actually have a lacquer that you apply to the outer surface of any substrate effectively, and then you activate that with the laser and then do your plating. So they're tool based and plating based. And there are also some sort of printing plus tool based type situations. One process at the moment is called laser induced forward transfer. So you would have a layer of silver type material or other material, the printing material, whatever you want to use, say on a glass substrate, and you fire a laser through that, and there is basically a forward projection of individual spots of material. So literally writing dot by dot and then line by line of circuitry. You also have in mold electronics, where you would screen print, for example, onto a 2D plastic substrate or foil substrate. You do your normal assembly of surface mount devices, and then you would hot form that to get a 3D shape, and then you would put that into an injection molding process and do overmolding. So that's actually becoming quite a well-established process in things like automotive for displays and human interfaces there. And you also have pad printing, so that's tool based in the sense that you have a tool that is pad of a certain shape, which basically just goes into your paste and then transfers that paste, presses that onto the substrate, and you can do that in 3D space. So with that, I'd like to thank you very much for your attention. Please feel free to contact me at Neotech. My contact details are there on the screen, or you can obviously find us on the internet.